This next problem, A9, problem set 10, looks much more difficult than it really is. Let me read the problem to you. It says, while swimming in her backyard, Nicole attempts to hold a 0.9 cubic meter inner tube. That's a pretty big inner tube. She tries to hold it down underwater, completely submerged. Now, that inner tube is going to be floating. So the only part that really is submerged is the volume whose weight is equal to the buoyant force, and that equals its weight because it's floating. But she's going to try to submerge the whole thing. Take that inner tube, and you've tried to do this before. You take that inner tube and you try to submerge it completely underwater, okay? And she's going to try to do that. Now, she's going to try to submerge it's a large inner tube, a point like a truck or a car inner tube, 0.9 cubic meters, 0.9, almost a cubic meter. Okay. It says, A, what buoyant force will be exerted on the inner tube as Nicole attempts to force it underwater? So you want to find the buoyant force of the inner tube that's completely submerged. So use that volume in that equation to get that buoyant force. Makes sense. Then it says, B, when Nicole lets go of the inner tube, it pops up out of the water up to the surface, pops it up, with a force of 8,990. So that's going to be the net force that the inner tube is going to have. Okay, that's the net force. So that will drive it up. In other words, I have the inner tube at the bottom of the pool, right? And it's going to have a large buoyant force. Okay, that's going to be the weight, and that's going to be the buoyant force. So the buoyant force is going to be significantly larger. Therefore, it's going to rise up out of the pool because the buoyant force is great. Okay? The buoyant force can be whatever you want it to be. The buoyant force is always the weight of the displaced fluid. That's it. The weight of the volume of fluid displaced. That's what buoyant force is. So if I have the whole thing submerged, it's 0.9 cubic meters will be the volume of the fluid displaced. Okay, so I'm going to erase this. Therefore, if you plug into this equation, it's the buoyant force equals 1,000 times 10 times 0.9. Okay, so the buoyant force is going to equal 9,000 newtons. That's what the buoyant force is going to equal. Now, if it shoots up out of the pool with that force, that net force, therefore, it's going to accelerate up out of the pool, and its true weight will be 10 newtons. So its weight equals 10 newtons. Okay? And that's going to be positive. Positive 10 newtons. Right? Down is positive, up is negative. Okay? So in other words, it's going to be the apparent weight equals, right, the weight minus the buoyant force. Okay? Minus the buoyant force. Or, well, if you're talking about net, it would actually be plus. Knowing that, you put the negative sign in afterwards. In other words, that would be equal FW and that's going to be minus 9,000 newtons. This will be 9,890. 8,990, sorry. Okay? And then that is going to be, because that's going to be going up. That's the direction. The net force is that way. Remember, we said up is negative, down is positive. So that's going to be negative because it's going up. So then I add 9,000 to both sides, and I get FW equals plus 10 newtons. So this is the F net, okay? This value here is 10 plus 10 newtons, okay? So the weight of the inner tube is plus 10 newtons, okay? The volume of the inner tube is 0.9. The apparent force, it's actually a net force, is going to be negative 8,990, okay? And what else? The buoyant force is 9,000 newtons. So think about it. Think about it. I calculated the buoyant force to be 9,000 newtons. Okay. That's up. So it's negative 9,000. Okay. That's the buoyant force. Okay. It's going to be net force. I'm going to erase this here. Okay, the net force is is the sum of the vectors, right? The sum of the vectors. So it's going to be FW plus FB, okay? Now, this is direction oriented. Up is negative, down is positive, okay? So we're given in the problem, as part of the problem, it said that when Nicole lets go of the inner tube, it pops up to the surface with a force of 8,990. So it's minus 8,990 newtons equals plus negative 9,000. Add 9,000 to both sides, you get positive 10 newtons. So I calculated 9,000 newtons. I know that 8,990 newtons is the net force. I know that net force equals the sum of the vectors. So I know that FW is positive, FB is negative. That's it. Good luck.